Hey guys, happy Thursday. All right, so another one page of notes, which is nice. So hopefully these will stick right around 10 minutes. That's a pretty short lesson, you guys, right? So if it's confusing, you should watch it again, watch it twice. I encourage you guys to rewrite these on different pieces of paper and to practice them and make sure you guys can get the same answers. We're going to do just a simple derivative here of logarithmic functions. The natural log function, this for sure is all over the AP exam. This would be very rare, okay, for them to ask you a question about taking the derivative of a log function. It's just not something that is used very often in calculus. It's not that we don't use logs, because remember, this is a log function. It just has a natural log, meaning it has a base of e instead of a base of 10 for the normal logs. Okay, so really, I would not spend too much effort on memorizing this stuff. If you're worried about it, honestly, I don't know that I'll put it on my assessment. I'm going to focus on the natural log function. And so what are the derivatives? Well, let's focus on the natural log one first, because this is the more important one. So if I have a y, I'm going to rewrite this as ln of stuff. Okay, the derivative of y would be 1 over the stuff times d stuff, or the derivative of the stuff. Okay, and if you memorize these silly things, it just works, right? That if you have a function y equals ln of stuff, the derivative is just 1 over it, whatever the stuff is, the argument, times the derivative of that stuff. Okay, all right, so let's go down and do a pretty basic one. I'm going to start down here at e. Okay, so y equals ln of stuff. So y prime would be 1 over the stuff times the derivative of the stuff. So the derivative of 5x is just 5. And so you would end up with the 5's canceling, and you would just get 1 over x. Okay. All right. Let's do how about this product one here? So let's come over here. So this is going to be a function and a function. And so we're supposed to do the product rule, which is old stuff, but now we have the abilities to take the derivative of natural logs. And so we'd say y prime equals. As a point, you guys, I'm just going to pause here for a second. If you remember back to Monday, we talked about implicit differentiation. This is not implicit, right? We have a function that's solved for y. So we're taking derivatives of these functions, which are both functions of x. So we don't have any of that weird dy dx stuff going on. Okay. So the derivative is the product rule. So it's the first times the derivative of the second. All right. The derivative of ln of stuff is 1 over the stuff times the derivative of the stuff. Well, the derivative of x squared plus 1 is just 2x. Okay. So again, first, product rule, first, x, times the derivative of the second, which is all of that stuff, plus the second, which is ln of x squared plus 1, times the derivative of the first, which is just 1. Okay. All right, so then let's clean this up. So numerator, so 2x squared all over x squared plus 1 plus ln of x squared plus 1. And that would be your answer. There's nothing else to do there. Okay, and so here we've got this answer, we've got that one. So let's come back up here and let's do maybe A. Okay, so A is saying, well, I've got y equals ln of x squared. We're set up to do, we're going to do the power rule. This involves the power rule and the chain rule, right? And the ability to take the derivative of natural logs. Okay, so y prime, let's use our simple power rule, which says, bring the 2 down in front times that complicated function to 1 smaller, times chain rule, the derivative of the inside stuff that we have not taken the derivative of yet. So what is the derivative of ln of anything? It's 1 over the stuff, which is 1 over x, times the derivative of the x, which is just 1. And again, right, rewind that, make sure you understand in your brain what happened. This is a power rule. Bring the 2 down times the function to 1 smaller. Now, we haven't taken the derivative of the inside stuff. That's the chain rule. So times the derivative of that. Well, what is the derivative of ln of anything? It's 1 over it, whatever your argument is, times the derivative of that, which is just 1. Okay, for a final answer of, you would just write that as 2 ln of x over x. Okay. All right. Let's come down here. This is also a natural log problem, and then we'll go back and do the logs. Okay, so I did mention, right, we can look right here. This is solved explicitly for y. And so we just do our rules. Right down here, this was solved explicitly for y. We just did our power rules. This was solved explicitly for y. You just do your rule. Up here, you are taking the derivative of this equation where you can't get y all by itself. Some of you might want to move the ln of x over and take the e to both sides. That's not how we're going to do this. We are just going to take the derivative with respect to x, term by term, because that's not solved for y. And so let's do it. What is the derivative with respect to x of this guy? Well, that's an x. And so I don't have to worry about dx, dx. It's going to go away. And the derivative ln of x is 1 over that x times the derivative of x, which is just 1. Okay? Then let's take the derivative of this guy. The derivative of this, now we have an issue because that's a y. Y doesn't match x, so when you take the derivative, we're going to get 1 over the stuff, which is 1 over y, times the derivative of y. Okay, well, what's the derivative of y? 1 dy dx. Okay, equals the derivative with respect to x of 2x is just 2. Okay, and so how do I answer the question? Well, I'm looking for y prime, or dy dx. So let's subtract 1 over x. So I have 1 over y dy dx equals 2 minus 1 over x. Okay, now to get rid of this 1 over y, I would multiply both sides by y, giving me dy dx, my answer, as y times 2 minus 1 over x. Maybe they distribute the y. I have no idea. Doesn't really matter. That's fine. If the multiple choice answer was 2y minus y over x, you would obviously pick that one. Okay, so those are very common. Taking the derivatives of the natural log function is just 1 over the stuff, d stuff. Okay. All right, so let's just do this because I have to do it. I have to show you guys, even though some years I don't even do this because it literally, I just never see it on there. What happens if you have a logarithm? Well, it's 1 over all these pieces, right? 1 over your stuff. We knew that before, just like the natural log part. But then it's ln of whatever your base is, right? And then times the derivative of all this stuff. And so you gotta just plug all that in, right? And so we have this 1/2 in front that we can just ignore, okay? Because it's a coefficient. And so it just kind of, you're not really thinking about it, right? Let's take the derivative of log of x. Well, remember, this is a base of 10. And so using my rule up here, it's 1 over the u, which is x. So I have 1 over x. And then I have ln of whatever a is, which is your base. So ln of 10 times the derivative of whatever your u was. Well, the derivative of u here would just be 1. Okay, and so you could answer this as 1. That 2 is a denominator, so you could just write 2x ln of 10. And again, you're just not going to see that. It just doesn't happen very often. Okay, so using the same rule again, we'll just jump in here. Y prime equals. We know that this stuff goes down below, so I know I have x cubed. I know I have to do ln of whatever that number is there, which is 2. Okay, and then up here, I'm supposed to multiply, right, by the derivative of whatever u is. U is the argument. And so down here, the derivative of x cubed would be 3x squared. Simplifying that, some of those x's would cancel, giving me just 3 over x ln of 2. And that would be my derivative. Okay. I like this first problem, but I want to do another one just because. We'll just practice. Okay, one more. So what if I told you we had y equals, let's just make it a little harder. Let's do ln of x squared cubed. Okay. And I like this because you get to practice a lot of rules. So the 3 would come down in front times the natural log of the stuff raised to 1 smaller, right? So all I've done is the power rule there. The 3 came down times that stuff to 1 smaller. Now I've never taken the derivative of that, which is what the chain rule does. And so now I need to take the derivative of ln of x squared. Well, that's our new rule from today. So the derivative of ln of x squared is 1 over the stuff times the derivative of the stuff. Okay, and again, you could practice power rule. 3 times that to 1 smaller. Derivative of the inside gives you 1 over the stuff, d stuff. Okay, and then simplifying all of that, 3 and a 2 are a numerator, so you definitely have 6. One of those cancels, so I end up with 6 over x, right? So I took care of the 3, this guy and that guy, and then I have that, which is, you could write it as ln squared of x squared, or you could do it in parentheses, all 2 squared. Either way, it would be correct. Okay, just another little example there. And don't forget, you guys, you have your textbook. You can always go find extra practice problems if you want to. But I think the homeworks that I assign will be good, and we will obviously spend a lot of time in the Zooms going over it. Take care.